Hello, Rusty. What's up, Rusty? What? Hey, draw. What grade are we in again, draw? Okay, so wonderful people, we want to just pick it up there with grade graphs, straight line functions, that is linear functions. So we're going to take it one step at a time and look through and go through linear functions, because that's an important topic covered in term 3 in this grade. Very important. Okay, so we're going to go over it. So first thing we need to note about a linear or a straight line function is that the general standard form of a linear function is y is equal to mx plus c. Now we need to be able to write our linear function in this form in order to be able to state the gradient. Okay, this m value here, when the linear function is in this form, this m tells us about the gradient, and what the gradient is what we refer to as the slope of the function. How is the function sloped? All right, in other words, the measure of how steep our function is. So the slope, or in other words, the measure of how steep our function is what we call the gradient. There is a formula that we can use to calculate gradient, especially when we are dealing with points on the Cartesian plane. All right, if we're dealing with points on the Cartesian plane, then we can use this particular formula to be able to calculate the gradient. But as I said to you guys, that whenever the equation of a straight line function is in standard form, we can actually read, all right, from the standard form what the gradient is, because the m value here, the m value points to the gradient. The c value, on the other hand, speaks to something else, which we refer to as the y-intercept. Now, what is the y-intercept? The y-intercept is simply the place where our straight line function intersects, or in other words, crosses, meets, overlaps the y-axis. All right. Now, when I talk about y-axis, okay, I'm talking about the Cartesian plane. When I'm talking about the Cartesian plane, I'm talking about a system of y and x-axis. All right, a system of y and x-axis. Our y-axis, of course, consisting of positive numbers, all right, above this x-axis, and then negative numbers below, right? So it's like a number line that is vertical. That's what your y-axis is. And then your x-axis is a number line that is horizontal, right? So this number line, obviously, at this point, we say that point is 0, okay? And then, of course, if you have your number line, you can list all your real numbers on this number line after 0, and then all your real numbers before 0 on the side of the x-axis. For the y-axis, you have your positive y values and you have your negative y values. So what I'm saying is this value of c for our straight line function or equation represents what we call the y-intercept. What the y-intercept is, it's the place where the straight line intersects. What does the word intersect mean? In other words, it's the place where the line will cross or meet or overlap the y-axis. That is what our y-intercept is referred to. Okay. So I repeat again, straight line function has the form y is equal to mx plus c. This is the form that any straight line function should always have. Y is equal to mx plus c, where m is the gradient. What is the gradient? It is the slope, right? It is a measure of how steep our straight line is. There is a formula to calculate gradient, all right? But if we are given the equation in standard form for the straight line, we can always read the gradient from the equation, right? But if we want to calculate, right, this here, this formula is used to calculate the gradient if given points on the Cartesian plane. Okay, so if we are given points, coordinates, right, on the Cartesian plane, then we can use this formula to calculate the gradient. Okay, now let's talk a little bit more about this value of m, the gradient. If the gradient is positive, or in other words, if the gradient m is greater than 0, this symbol here stands for greater. So we read this as gradient is greater than 0. If the gradient is greater than 0, anything greater than 0 means it's a positive number, right? So if the gradient is greater than 0, then we can expect a straight line that is sloping upwards. I repeat, if the gradient of the straight line function is positive, in other words, it's greater than 0, then we can expect to draw a straight line function that is sloping upwards. Okay? In other words, a rising straight line. Okay? But if the gradient is less than 0, meaning it's negative, then we can expect a straight line that is sloping downwards. Okay? If the gradient is equal to 0, then we can expect a straight line that is horizontal. And lastly, if the gradient is undefined, meaning if m is undefined, then we can expect a vertical straight line. Okay, so this is very important. M greater than 0, straight line slopes upwards. Gradient less than 0, meaning it's negative, straight line slopes downward. If the gradient is equal to 0, we have a horizontal line. Gradient is undefined, we have a vertical line. Okay, so these are important points to note about m, the gradient. Whenever the equation is in standard form, like I said, we can read the gradient from the equation, right? And then if we don't have the gradient, but we are given points on our Cartesian plane, we can calculate the gradient using this formula. Our gradient, furthermore, if we find that the gradient is positive, our straight line, when drawn on the Cartesian plane, will be a straight line that is sloping upwards. the gradient is less than 0, meaning it's negative, it will be a straight line sloping downwards. If the gradient is equal to 0, we have a horizontal line. If the gradient is undefined, we have a vertical line. Okay, and there's a bit of commentary here about when the gradient is positive, it means that it slopes upwards. It means it rises as we move from left to right. The straight line simply rises. Okay, if the gradient is less than 0, it means it's sloping downwards. It simply falls from left to right. So from left to right, the straight line simply falls, okay, because it's sloping downward. If the gradient is equal to 0, it means that there is no slope, okay, because there's a constant y value that our horizontal line is actually having to go through. But if the gradient is undefined, then we know that is a vertical slope, meaning it is infinitely steep, and there's a constant x value that this vertical line will experience. So I hope that is very helpful and very enriching for you to be able to know this information about the general standard form of a linear function. That is what you can read from it, the gradient, all right? And depending on whether it's positive, negative, equal to 0, undefined, this is the sketches that you can anticipate as you anticipate to see how the graphical representation of the straight line will be. The c value, like I said, which is the c value here on the equation of the straight line, that c value tells us about what I refer to as the y-intercept, the place where the line, meaning the drawn straight line, will intersect. In other words, where it will cross, meet, or overlap the y-axis. Okay, our straight line will forever, if let's say for instance we drew a straight line like that, let's say that's a straight line, okay, it will overlap or cut the y-axis. All right, and where it cuts the y-axis, that means that's our c value right there. Okay, so obviously we can expect a c value that is positive here because the y values here are positive. But if let's say the straight line is a straight line like that, okay, cutting through the y-axis at a negative value, then we can expect that our c value will be a negative value. Okay, so basically that's what we call our c value. In other words, the y-intercept. It is the place where the straight line will intersect. In other words, what does the word intersect mean? Where it will cross, meet, or overlap. So you can see most that the straight line here is crossing through the y-axis. It is meeting the y-axis at this point. It is overlapping the y-axis at that point. These are just synonymous words to sort of explain what the word intersect means. Okay, so that's what the c tells us. It is the y-intercept. Okay. Now something else to note that is just, very, very beneficial to note and know is that whenever we have what we call lines that are parallel on the Cartesian plane, parallel lines that are parallel, they have equal gradients. So an important defining feature or characteristic that parallel lines possess is that they have equal gradients. So what we're expecting is that if this is, let's say for instance, line 1 and this is line 2, the gradient m of line 1 will be equal to the gradient m of line 2. Parallel lines have equal gradients. Okay, so I could, for instance, know what the gradient of, let's say, this line is, this one. Let's say I was told that the gradient of this line is 4. If this line, the second one, is parallel to this one, then I can tell you without a shadow of doubt that the gradient of this line is also equal to 4. All right. Why? Goes back to this, that parallel lines have equal gradients, right? So we say the gradient of line 1 is equal to the gradient of line 2. Why? Because the lines are parallel. Okay. Then our next point is that perpendicular lines. Now, this word perpendicular, what does the word mean? The word perpendicular simply means two lines that meet, overlap, okay, and make an angle of 90 degrees. That's what perpendicular means. When you have two lines, they meet and they make an angle of 90 degrees. That's what perpendicular lines are. So what do we know about the gradient of perpendicular lines? Simply put, the gradient of perpendicular lines, let's say this is line 1. Let's say that this vertical line is line 1. And then let's say this line is line 2. They are perpendicular. What we expect is that when these two lines, we multiply their gradient. When we multiply the gradient of these two lines, what can we expect? We'll expect that when we multiply the gradient of these two lines, we will get an answer of what? Of -1. So, simply put, we say that the product of the gradient, this word product means the multiplication of the gradients. That's what the word product means. The product of the gradient of lines that are perpendicular will equal -1. The product of the gradients of lines that are perpendicular will equal to -1. Okay. So I hope you guys can also take into heart that important concept that parallel lines have equal gradients. All right. Parallel lines will always have equal gradients. But perpendicular lines, what we know about them is that the product of the gradients of those lines will be equal to -1. Hence, we are saying m gradient of line 1 times gradient of line 2 should give us what? -1. Why? Because the two lines are perpendicular. Right. Okay, guys, that was a lot of meat. But to quickly recap, what have we done? We've looked at linear functions. Just the fact that linear simply means it's a line, L-I-N-E. That's what we are saying. This here is a line function, a straight line function, that is. Okay. The standard form of this straight line is y is equal to mx plus c. The x is in the numerator, the m is in the numerator, the c is in the numerator, the y is in the numerator. Our x, whilst being in the numerator, has the exponent 1. That's why we say linear, because the x has the exponent 1. If the x had the exponent 2, it would not be linear anymore. It would be something else. But a straight line function is unique in that its x has the exponent 1. It is the only x in the expression, and it then has the exponent 1 as the only x there. M stands for gradient, as we explained, slope. Okay. If we are given the equation in standard form, we can read the gradient. If we don't have the gradient, but we are given points on a Cartesian plane, we can calculate the gradient by using this formula. M is equal to y2 minus y1 over x2 minus x1. We calculate the gradient if given points on the Cartesian plane. We use this formula. If m is greater than 0, we can expect a sloping upward straight line. If m is less than 0, it's negative, we can expect a sloping down straight line. If m is equal to 0, we can expect a horizontal line. If m is undefined, we can expect a vertical line. And then lastly, I said c. Our c value, the constant that is here, represents something called the y-intercept. This is not the gradient, it is the y-intercept. What is the y-intercept? It is the place where our straight line, when drawn, intersects. What does intersect mean? Cross or meets or overlaps the what? The y-axis. So I draw some examples here. If we have a straight line there, that straight line cuts this y-axis at that point. So whatever that value is, it is the y-intercept. This straight line cuts this y-axis at that point. Whatever that value where the straight line cuts the y-axis, that would be our c value. And lastly, what did I say? I said parallel lines have equal gradients. The gradient of line 1 would be equal to gradient of line 2 if ever those lines are parallel. What are parallel lines? Parallel lines are lines that are far apart by a distance that is constant and they never meet. But what we have now learned is that those parallel lines, as they move in the same direction, we know that they have equal gradients. But if those lines are perpendicular, what are perpendicular lines? Lines that meet at 90 degrees. Where they meet at 90, make an angle of 90 degrees, a right angle in other words. Perpendicular lines, what do we know about them? The product of the gradients of perpendicular lines will be equal to -1. Okay, guys, that is so important for someone who is wanting to really have a good conceptual understanding of what a linear function is. So let's dive into some examples so that we can explore an option of straight line equations and see if we can, from those straight line functions, identify m and c. So let's just write an example here. Let's say this is example 2. I already have an example 1 there and I'll show you just shortly, but I want to start off here. Let's say we had y is equal to 3x plus 1 as an equation of our function. So first and foremost, is this equation a representation of a linear function? Is this equation a representation of a linear function? In other words, is this equation representing a straight line graph? Is it? Right? And is this equation in standard form? So those are two questions that I'm asking. Is this a representation of a straight line graph? If you're saying yes, it is, then is this equation in standard form? All right. So if you remember the standard form, y is equal to mx plus c. So is this equation in standard form? It seems like Star Life is saying yes, yes. That's a double yes from Star Life. All right, and I agree with Star Life that indeed this equation is in standard form. Can I then now tell you what the gradient is because the equation is in standard form? Can I now tell you what the gradient, the value of the gradient is now that the equation is in standard form? Can I tell you what the gradient is since the equation is in standard form? All right, and the answer is yes. So what is the gradient of this straight line function? Remember, the gradient is represented by m whenever the equation is in standard form. M, the coefficient of x, is the gradient. So what is the value of m here? What is the value of m here? What is the gradient? So we can write m is equal to what? What do you guys see? Can we see the value of m from the equation in standard form? Hopefully we can. So our value of m, very good, Onta, is 3. Okay, very good. Thank you, Onta. Then, what is the value of c, the y-intercept? What is the value of c in this standard form equation? Can we see the value of c? Can we indicate what the value of c is? Hopefully we can. I hope we are confident in stating what the value of c is. So can I write it down? C is equal to what? Positive 1. All right. Okay, done and dusted. That wasn't too hard, was it? All right. Once the equation is in standard form, writing down the value of the gradient is easy. Writing down the value of c is very easy. Furthermore, we know that this c value is a representation of the y-intercept. Okay, very important. Let's go to another example. 8y plus 2x is equal to 16. My first question to you, is this equation 8y plus 2x is equal to 16, is this in standard form, guys? Is this equation already in standard form? Yes, no? Is the equation in standard form? Okay, thank you very much. I'm glad that people can resoundingly say no ways, Jose. Yes, this equation is not in standard form. Not by a long shot. Okay, so then what can assist us then to make sure that the equation is in standard form? Well, we are going to have to make sure that we can actually get it to be in standard form. How are we going to do that? So we are going to rewrite the function 8y. Okay, now this 2x does not belong on the left hand side because it's 8y plus 2x. There are two terms on the left hand side of the equation. So what do we do to this 2x? Well, we are going to transpose the 2x. In other words, we're going to take the 2x over to the other side. It becomes what on the other side? It becomes negative 2x. Okay, do we see that? Then, what did we have already on the other side? We had a plus 60. Okay, it seems like we are very close. Is the equation now in standard form, guys? Can we now comfortably say that the equation is now officially in standard form? Is it? Is the equation in standard form? Okay, Onta says yes. Now, Onta, I'm gonna say that we are close to having it in standard form. The only problem is that unlike this one, what are we expecting? We're expecting that our y value does not have a coefficient of 8, but rather our y value has a coefficient of what? Of 1. So how do we make sure then that this 8 that is here is actually now removed so that we can have a coefficient of 1 yet again that belongs there before y? What do we do, guys? What can I do? I want y to not have a coefficient of 8, but I want y to have a coefficient that is 1. So how do I ensure that that is actually a reality? What do I have to do to this equation? Thank you. Very good. Wow. Divide both sides. I heart pound. Divide both by 8 on both sides. So let's go ahead and do that. Okay. This is just us applying our knowledge of what we would do when solving for an unknown, like we did last term when we were solving for x. So that means we divide by 8 for all the terms that are in the equation. Okay, now 8 divided by 8, you are going to know will leave us with 1 there. So that 1, we can write it down, or we can just not write it down. That still means that our 1 is there. Then, what's negative 2 divided by 8? Now we can see that 2 goes into 8 4 times. So 2 is the highest common factor between 2 and 8. How many times does 2 go into 2 in the numerator? Once. How many times does 2 go into 8 in the denominator? 4 times. And then of course we need to write down that negative sign which was already there. Okay, then we don't forget the x. Okay, then 16 divided by 8, that is 2. So we can say y is equal to negative 1 over 4x plus 2. Okay, someone else could well say y is equal to negative x over 4 plus 2. And I'll tell you this, that this here is the same as that. Those both mean the same thing, right? Okay, so this is what's important, guys, that whenever the equation is not in standard form, we need to get it to be in standard form, okay, by ensuring that we apply both the additive inverse by transposing, and then apply the multiplicative inverse by making sure that we divide by whatever coefficient that y has. Okay, so then, yeah, that's what we call applying to transpose something, to take something, right, move it to the left hand side and the sign changes, to the right hand side and the sign changes. That's applying the additive inverse there. Then this division of by 8 for all terms is applying the multiplicative inverse or the reciprocal. So what is the value of m then? Let's see if people actually have an idea. What would we then say is the value of m here? Hopefully you guys can see the value of m. The value of m will be, let's give people a chance to respond. Maybe not steal your shine. M is? Okay, so m is a negative 1 over 4. Okay. The coefficient of x is my m, right? So when the equation is in standard form, I can simply read, okay, from the equation what the value of m is. And in this case, it's a negative 1 over 4. Okay, please guys, don't forget that. And then my c value, that's simple. The c value is a positive value. It's 2, so the c value is a positive 2. Okay, and that's that. Okay, that wasn't too hard, was it? Okay, remember when we had the equation in standard form, we can read the gradient. The gradient here was 3, the y-intercept was positive 1. Now in this equation, remember we didn't have the equation in standard form, so we need to get it to be in standard form. We transposed the 2x, got negative 2x plus 16. We divided by all terms the 8, and then after that we simplified. Y is equal to negative 1 over 4x plus 2. What is the value of m? Coefficient of x, negative 1 over 4. Value of c, the y-intercept, it is 2. Okay, not too shabby, guys. I hope we are seeing this and we are seeing it well. Okay, it's very important to know how to get the equation from that form to this form, and then being able to extract or read the gradient value. It makes life so easy. Okay, now I want to step into this world. Okay, the gradient or slope. How do we determine the slope of the line between? So we're going to look at all three of these scenarios. We've got scenario 1. They want us to determine the gradient or the slope between what? Negative 2 and 1 and 3 and 4. So we need to look at number 1 first. Number 2, 4 and 1, 4 and 5. Number 3, 2 and 3, minus 5 and 3. So let's look at these individual examples and try and find the what? The gradient, because that's what they want. So what do we then see here? All we can see here is what we refer to as our points on the Cartesian plane, or we refer to them as coordinates. Okay, now minus 2 is how we read this. This is a bracket. Inside the bracket we have minus 2. We refer to this as the x coordinate. So x is always first. Then we have a semicolon. This semicolon means and. It doesn't mean 2, it means and. So we have 2 and 1. So this is x and y. So here we have the y coordinate. Are you with me, guys? I hope you are. So negative 2 and 1. This negative 2 is the x coordinate. This 1 is a y coordinate. And 3 and 4. Obviously, this is also x. This is y. So what we want to do is we want to determine the gradient of these 2 points. How do we go about calculating the gradient between 2 points? Well, didn't we just learn earlier on from our notes that if we are to calculate the gradient if given points on the Cartesian plane, we can use Mr. Good old formula to be able to do that. Okay, so let's go and write down the formula. The formula is m is equal to y2 minus y1 over x2 minus x1. Very strategic in how we've written this down, because y2, so the 2's start. Okay, the x is always at the bottom, the y is at the top. So y is at the top, x is at the bottom. Just is what it is, eh? All right. So if we look at these 2 points, okay, what we do is we are going to write down the minus 2 and 1, my grade 9s, and then we are also going to write down the other point, 3 and 4. Then you need to figure out in your mind which one would you want to be your first pair of coordinates and which one would you like to be your second pair of coordinates. So if you then decide that this is your first pair of coordinates, then do you know who this becomes, this negative 2? It not only becomes x, but it becomes x1, because you said this is your first. And then this 1 becomes your y1, because you said this pair is your first. So this becomes x1, y1. Then if you go ahead and you say this is your second, then this automatically becomes x2, and that becomes y2. Please take note, guys, that this 2 simply refers to the pair position. This was pair 1, so that's why it's x1, y1. This is pair 2. This is x2, y2. Guys, we are consistent in how we write x2, y2, because we say this is the entire second pair. We can't, for instance, say this is x2 and say y1. No. As the second pair, this is x2, y2. As the first pair, this is x1, y1. Why do we do this? It makes it so easy for when we have to actually substitute into the formula. All right. So, understanding that this is our first pair, this is our second pair, and please take note, you could, if you wanted to, say this is your first pair and then this is your second pair. So whether you say this is your first or second, this one's second, is this your first or second, it doesn't matter. What matters is that if you say this is your first, then you know this is x1, y1. If you say this is your second, this is x2, y2. And all we do is we substitute and plug into the formula. So the formula is already there. It's m is equal to y2 minus y1. You need to understand the change of y over the change of x. I hope that makes sense. Now, we can now substitute into the formula, the gradient formula, which makes life very nice and sweet. So, this is m is equal to y2 minus y1 over x2 minus x1. Who is my y2 so that I can go and substitute? Well, my y2, okay, is going to be my 4, right? And then please remember, okay, that the formula already has a negative sign. So you write the negative sign that is in the formula, then you check what is y1. y1 is 1, okay? So we have 4 minus 1 there at the top. At the bottom, it says x2. So that is 3. And then x1. Remember, there's a minus sign already in the formula. And then we're following it up with another minus sign. So we, out of caution, make sure we put this second number in brackets. Why? Because it has a negative sign, right? And we know that when there's a bracket and another sign, that means we need to resolve that sign by asking ourselves, what's a negative times a negative? And I'm sure you guys are like saying the answers in your head right now, that a negative times a negative is positive. Then we can move from there and say 4 minus 1 is 3, 3 plus 2 is 5. So that means that the gradient of those 2 points gives you 3 over 5. The gradient of these two is 3 over 5. Okay. Now that wasn't so bad, was it? Okay. Do you see how simple it is? Think you can do it? Okay, you think you can do it? Well, I hope if you can, and it's making sense to you, guys, this is how we calculate the gradient of a line. All right. So if we come over here, we're going to look at number 2 and look at number 3. All right. And I'll really be happy if you guys are sitting there, you have your pen out, and you are taking down some notes, of course, because these are quality, weld title kind of notes. Okay. It's like world champ notes. Okay. So what I would like then for us to do is to do how to calculate the gradient for these 2 points and those 2 as well. Okay. So I hope the calculations are going down. You guys are doing the most there. Calculating the gradient of 4 and 1, 4 and 5. So 4 and 1, 4 and 5. So once again, 4 and 1, 4 and 5, we must choose who's first, who's second, so that can allow us the opportunity to label. So if we say this is your first pair of coordinates, that means this is x1, y1. This is your second pair of coordinates, this means this is x2, y2. And so already I'm sure you guys can see that x1 is 4, so is x2. Okay. And if you think about the gradient formula, we kind of have an idea what is going to go down and who's going to be affected. So let's try and stick to m is equal to y2 minus y1 over x2 minus x1. If you're sitting there and you're wondering, can't I write y1 first and then write x1 first on this side? That would be great. If you're starting with the 2's, you end with the 1's. If you start with the 1's, you end with the 2's. You know, we don't try and be haphazard. So let's go ahead now and actually go and look at the points. We have 4 and 1. We have 4 and 5. First point, that means this is x1, y1, this is x2, xy, x2, y2. So let's go. What's y2? Y2 is equal to 5. There's a minus sign already in the formula. What's y1? That's 1 over. What's x2? X2 is 4 minus, what's x1? X1 is 4 as well. Now I'm sure you guys can see that this is 4 over 0. And what is 4 over 0? Undefined. So that means our m value is undefined. And if you remember very, very well, I explained that whenever m is undefined, it means that our straight line won't be horizontal, but it will be a vertical line. Okay. And what is it about it being a vertical line? There's constant x values. Now let's go and check there when we were writing down our points. For this point, what is the x coordinate? It is 4. For this point, What is the x-coordinate? It is 4. So what do you notice here? You have constant x values. In other words, the word constant means the same. Okay, the same. All right. Teddy said, you are saying, I must show you the notes. So this is what I started off with at the beginning, right? Explaining how the equation of a straight line, okay, or what we call a linear function, is written in that form. Y is equal to mx plus c. M is the gradient, or what we refer to the slope. It's the measure of how steep our function is. The formula that we can always utilize if we are not given the equation of the straight line and we can't read the gradient from the equation, we can always calculate the gradient by using this formula, which I'm currently using at the moment. Okay. Then we said that if m is positive, we're expecting a straight line that slopes upward. If gradient is less than 0 is a negative, we're expecting a straight line that's sloping downwards. M is equal to 0, it's a horizontal line. M is undefined, it's a vertical line. And then these are just notes that basically are giving us further that, for instance, a horizontal line has no slope, but your y values will be the same on this horizontal line. For your vertical line, there's a vertical slope, of course. It's infinitely steep, and there'll be the same x values throughout that straight line. Hence, for instance, this vertical line here, if you look at the points 4 and 1 and 4 and 5, who is the same here? It's the x values. The x values are what? Are constant. That's for what? When m is undefined, you're expecting a vertical line. So we just calculated the slope or the gradient for 4 and 1, 4 and 5. And what we found is 4 over 0, and we know that when a number is divided by 0, it is undefined, which means the gradient is undefined. Okay. Then we spoke about c here, that our c value speaks about the y-intercept, the place where the line graph will cross, meet, or overlap the y-axis. Like you are seeing these straight lines overlapping the y-axis there, the straight line also overlapping the y-axis at that point. And then I mentioned that parallel lines have equal gradients. If lines are parallel, guys, the gradients are the same. They are equal, they are constant. But if the lines are perpendicular, in other words, they meet at right angle, 90 degrees, then we know that the product of the gradients will give us -1. Okay? For perpendicular lines, the product of the gradients equals to -1. We then looked at how to identify the gradient when the equation is in standard form. So this is in standard form, the straight line function is m is the gradient, so m is equal to 3. C is the y-intercept, so c is equal to 1. That would be our y-intercept. We had this function. We quickly saw that this one doesn't have a standard form. Okay, it's not in standard form at the moment. So that means we need to take the 2x over, and when we do look at this, we get -2x plus 16. We then divide by the coefficient of y, which is 8, for all three terms here, so that we get y is equal to -1 over 4x plus 2. Now we can actually read the gradient from the equation, because the coefficient of x when the equation of the straight line is in what? Standard form, allows us to read the gradient from the equation itself. Okay, and we're able to do that and get the y-intercept as well. Now I was busy on how to calculate the gradient between 2 points if you are given to them. So we did this calculation quite successfully, because we did note that whenever we want to calculate the gradient, we must first say to ourselves, who's the first, who's the second. So this is the first pair, second pair. This is the x-coordinate, the y-coordinate. This is the x-coordinate, the y-coordinate for the second pair. So that's why if you say first, it means x1, y1. This is the second, this is x2, y2. It makes it easier for substitution once we identify. And then please, guys, remember that the formula already has its own minus signs. So if you find out that the number that follows after the minus sign is also negative, then it means you need to resolve the sign. Hence we get 3 plus 2 in the denominator, and then the final answer for the gradient is 3 over 5. Okay. Now we looked at this one, number 2, when the x values are constant, m is undefined. That's what we're expecting. So indeed, you can see that when we substitute it into this formula, the 0 denominator is there, which means the gradient is undefined. Then let's check out the last one that we have there. M is equal to y2 minus y1 over x2 minus x1. Where's the points? 2 and 3. The other points, -5 and 3. What do you guys notice? I'm sure you noticed that the y value is also at this time what? Constant. If the y value, guys, is the one that's constant, then listen up here. If the y value is the one that is constant, it means that this is going to be a what? A horizontal line, okay? Because the y value is constant for our horizontal line. There is no slope because this is a horizontal line, okay? So yeah, y values are constant, so we're expecting that the gradient will be 0. But let's check, okay? So if we go ahead, this is our first pair. If this is our first pair, that means this is x1, y1. This is our second pair, that means this is x2, y2. So all we can do is just substitute. We have y2 already here, which is 3. Remember, the formula already has a minus sign, and then it's 3, and then minus 3 in the numerator. In the denominator, we have x2, which is -5, minus who? And then it's 2, which is positive. But we know a negative times a positive is a negative, hence we got that there. 3 minus 3 is 0, over -7. So obviously our gradient is equal to 0. And what does that mean? It means if we drew this straight line, we would see a horizontal line. Okay, very, very important. Okay, guys, that is as much as I'm going to do for today where the straight line is concerned. Tune in next time when I do a live for grade 9s, because I will then extend this further, all right? And we will look at how to sketch our graphs. For now, what we have looked at, I think, is good for an introduction. How to find the gradient if the equation is given to us, but more importantly, understanding that our gradient can only be identified if the equation is in standard form. And then also, obviously, our c value, our y-intercept, can also be identified from the equation of the straight line if the equation of the straight line is in standard form. That's very important. And then, of course, the A-game knowledge that we learned today, that for parallel lines, we know that gradients are equal, but for perpendicular lines, the product of the gradients will actually afford you a -1. Okay, so yeah, I hope that was very beneficial, helpful, and enriching. We will go a little bit deeper into this as we go along, of course. Just be patient with me. We'll be doing other things as well, but for now, I think this will suffice for today, my beloved grade 9s. So hopefully you guys can do what now? You can make sure that you just solidify the info that you have been so blessed to receive freely on this platform. But thank you so much. Thank you for those that joined in. If you're joining in for the first time, you're very welcome. And please do make sure that you do return next time and next time and next time. And thank you so much for your time. Thanks for those who followed me, followed the live creator as I was going along. I really appreciate the love and the support. And please do have a wonderful evening further. Masters Again loves you guys. You have a great time. Thank you so much.